Hello all. In this video, I'm going to take a look at the Colab notebook that I've prepared that my students in my class, if you're watching, are going to be working through to experiment with using and then eventually even training a YOLO model to perform object detection and image segmentation. This is amazingly easy to do. I appreciate that Ultralytics has made their model so easy for even relative beginners to figure out how to use it and to do interesting things with it. So here's the start of the Colab notebook. I'll note that, as always, you have all of these options. We actually, in order to do some of the things in the activity, we are actually going to need to upload some images. I have already done that. So let me show you. I've actually already run some of the things here, so I uploaded this file, images.zip. I have a little code block that I'll show you in a minute that will unpack that and make this folder full of images. These are just some random images that I selected. Some of these are ones we've used earlier. I wanted to experiment and see how YOLO's model would work. This is YOLO version 11 that we're working with, which is the current version, but we're also using the smallest and therefore the least accurate of the models. That's just to keep the runtimes short and keep the model light so it doesn't take as long for us to work with it. You could easily try one of the larger scale models, probably get better and more interesting results. So I wanted to see the YOLO version 8 model comes pre-trained on the COCO dataset. This is one of the benchmark datasets. And I wanted to see how well it would do on some random images. So that's one of the things that we'll be trying. I'm going to show you the results, but I'm going to leave how you actually get those results a little bit of a mystery for my students who are going to be working on this activity. You can see here that also there are two YOLO models that are already downloaded. There is in fact a code block that causes that download to happen, and I've just already run that, so it's here already. All right, so there's some text here that just kind of tries to orient you to what we're doing. We're going to be experimenting first with object detection and then with image segmentation. And so the very first step, and this is a code block copied from Ultralytics' own examples with a few minor changes. This actually installs Ultralytics in my Colab notebook. I originally was using YOLO version 8, and I found that that had some incompatibilities with other modules that were installed here. So I just changed it, and I made it just install YOLO version 11, and that worked just fine. You don't really need to understand everything that's in here, but it's not too hard to see this when you write this in when you write a command in Colab and it has an exclamation point at the start. That is actually a command that you would otherwise type in a terminal. And we are not typing it in a terminal, we are typing it in a code block, but it allows us to incorporate terminal commands into the code that we write so that Colab can figure it out. When it sees that line, it knows to go and run that in the terminal. So this will install Ultralytics. This just clears the output from this box. So there's a lot of messages that get printed when you do a pip install. This sets up so that Ultralytics won't be tracking what we're doing, and then it runs a check to make sure that the import worked correctly. So you should be able to run this. There's a lot of output, but it shouldn't generate any error messages. The next step is just importing things. We're going to be using YOLO. I'm also importing the zip file. I don't know that we're using CV2MShow to display the results from the YOLO model because the YOLO models appear to use OpenCV's style of image representation as a NumPy array in the blue, green, red order instead of the red, green, blue order. I don't think we actually use CV2, but I'm leaving it there because you might want to. All right, so the next thing I have here is just a little code snippet. This actually does the unpacking of the zip file. I find that often with Colab, it's just way faster to move around zip files and then unpack them through the notebook itself. So that's what that's doing. The next thing we're going to do is to write, this is all using the Python API that Ultralytics provides. We are asking YOLO to create a model, and I'm asking it for YOLO 11N. And the fact that I'm asking for it in this format is telling it I want it pre-trained. So YOLO 11, by default, that's an object detector. It wants to find bounding boxes around objects and categorize them. And the N is just the smallest version of it. If you run this and the file has already been downloaded, you already have the model, it won't just set it up in Python as a model. If it's not already downloaded, it first downloads the model and then loads it in and sets it up. All right, the next the next block is actually running the model on some sample data. So you can call this method predict, and you tell it the source. The source can be one individual image. It can be a list, which is actually put in as a file name, a path. You can put in a list of paths to images, or you can do what I've done here and specify a folder. If you specify a folder, it goes through all of the images in that folder. I believe that this conf out here is a threshold, so if it detects an object but the confidence value is below 0.25, it doesn't report it to us. It'll report anything higher than that. And you can see it does a little printout of the results for each of the images in our sample. But it also returns those results as a list of results, one for each image, and we can then unpack those and see the result. So I have a function that I've defined here called display result. I'm just providing this to you. This uses the built-in, YOLO provides a plot function which does a really nice visualization of the image, and it draws the bounding boxes and it labels them with confidence and category in a really nice way. So I'm using that and then I'm displaying it, but I also want you to see that you actually have access to that data. It's not that hard to access, and so you could actually do your own annotations, draw them, or actually use the data in some way if you wished. So here I am going through the classes that it found. So for all of the objects it detects in the image, result.boxes.cls is a list of the categories as integers, as numbers. I'm pairing that with a value I because I want to also look at the corresponding values that are other parts of the results that you get. So we have result.boxes.cls. That's going to be a list with a category number in it. We have results.boxes.xyxy. That gives you the coordinates, upper left corner, lower right corner for the bounding boxes. They correspond to those classes. It's a list the same length. It's actually a tensor. But it's a linear collection, the same length as the class one, and they correspond to the same object that's been found. There's also result.boxes.conf, which has the confidence values, and again, it's a tensor, but you can think of it as a linear structure. It's like a list, and the corresponding values correspond to the confidence for the bounding box that was found. So I'm going through and iterating over the categories. This is a notation I haven't introduced in my class. It allows us to pair that up with the index, so we can do both index and value all at once. So I is an index into this tensor, and categ is the value. It's actually a tensor itself, but it's one value out of the original linear collection. I'm converting that to an integer. And then I am using that to index a variable name, a category name attribute that this result also has. So I can look up the category names and use the category number as an index to give me the corresponding name. And I am printing that, and then I'm printing the confidence and the bounding box. So this is essentially printing the same information that is plotted, but sometimes it's nice to see that, and it also shows you how you can go about getting your fingers in the code on the actual data and not just looking at the results. All right, the next thing we're going to do, I'm not going to show you the code to do this because this is what my students are going to do in their activity, but I basically looped over all the results and called this function on them. And I want to show you what those results look like. Not every single one. Let's see if I can. It's always a trick in Colab to scroll properly. I think that's working. Okay, so this was the first picture. It found the 2 cows with a high probability. Confidence is high. And then just so that we can see what's going on here, it's showing us the cow and oh, my confidence values are not printing right. So I'll have to fix my function. It's probably got a little glitch in it. But you can see the bounding box coordinates. You can see the confidence and the actual index of cow in its list of categories. We do the same thing with the train. You can see the value there. Here we have a picture. This is not, those first 2 were from the actual data set. I believe this one is not. And you can see that it's not particularly perfectly accurate. It's identified a salt shaker as a bottle. It probably doesn't have a salt shaker as one of its categories, so that's the closest it's going to come. It thinks that this one in the front is a pizza. You can see why. Maybe the check cloth didn't help it. So it's not quite right there, but it may not have anything for a fancy hot dog like this. It also has a dining table in the back, and it's, I think, mistakenly identifying something here as a person when it really isn't. It's hard to tell exactly what it thinks is a person. But again, my function will also print out the information so you can see it in a textual form, and you can see how you could actually use that in your program. Fire hydrants and people does the same thing. It finds people in a picture of folks climbing on a rock. It finds a bird. Actually, I think it finds 2 things it thinks are a bird, but one of them is actually the bald eagle. One of the things that's interesting here and that I want you to think about, because really we're talking about what can we learn about this model just from looking at these examples. Certain objects it identifies. Other objects in the picture, it does not. So notice we have this lovely picture of a butterfly, and it didn't find any objects in there. It wasn't trained on butterflies. That's not an object it was trained to find. It was trained to find birds. It does a nice job of finding the California condor here. Was not trained to find mountains or trees, obviously, because all it identifies is the vehicles on the road. It actually doesn't do so well, as you can see, with things that are not photos. So we have a couple of examples of clip art type images, and it misidentifies this one as a person, and it doesn't see anything in this other one. That's just not the kind of data it was trained on. Again, here, not trained to identify buildings, but it does find the people in that picture. I kind of like this one, as it makes sense to me. It does not identify coins. Clearly wasn't trained for that. It thinks maybe they're clocks. And I ran this a slightly different version of the model earlier, and it thought that one of the coins was a frisbee. So it's doing its best, but it was never trained to do this. Similarly here, we have a picture of some daylilies in a yard. It thinks they're a potted plant because that was in its data set, and flowers alone were not. Does a nice job with the dogs, identifying them, but is not intended to identify anything else that might be in the background. It does misidentify this dog as a horse. It has had a problem with this picture. I've used various versions of the YOLO model, and sometimes it thinks it's a dog, sometimes it thinks it's a horse, sometimes it thinks it's a bear. So it doesn't know quite what to do with that particular view of the animal. Here it's actually, this is as good as I would expect it to come up with. This is actually not a boat. It's a structure that is in the water that people are climbing on and jumping off of on a hot day. That's in Duluth, Minnesota. It misidentifies a dead log as a bench, which seems reasonable to me. And again, it's only really finding people. If we look at this this picture here, there are a lot of objects it could identify here. It's not doing a terrible job. It's not doing a great job either. So it's mostly correct, but it leaves a lot of things out. And sometimes it'll misidentify various objects. Like it's in some versions of the model, it will think this is a refrigerator because that's what it's seen more of. All right, so this just shows you lots and lots of outputs. Again, not trained to detect buildings, but it does a nice job detecting those umbrellas in the foreground. I know. It's kind of fun and interesting to see what it does. Doesn't know mushrooms, that's for sure. So it's worthwhile just playing with a pre-trained model and trying a lot of different images just to see what it's able to do and what it's not able to do. So that's a big part of the activity that we'll be doing. And so I'm going to ask you to actually spend some time thinking about this and writing up what patterns you see and so forth. The next section in the activity talks about running a segmentation model. So I'll go ahead and set that one up. And I'll run it again. I'm not actually, these are old results I'm going to show you because I don't want to show you the code. So this was from a little while ago. So again, these are the same pictures. What you can see here is that this is doing image segmentation. So it is highlighting the pixels that it believes belong to the objects that it has identified. So that's image segmentation. It's a more complex task. It's a lot more work to prepare a data set for this. It does pretty well, although it's actually missing part of the cow's head. I never really realized that. But it is identifying the edge of the cow fairly accurately. Does the same with things like the train. You can kind of see that it's finding the pieces we expect it to find for most of these. It does a particularly nice job on people. I think there were a lot of pictures of people doing various things in the data set. Here it does not actually success. This is a different model, right? This is the segmentation model in YOLO version 11. It does not identify that bird. Can't quite find it. But it does find the California condor very nicely. And again, we can see the pixels that it's picking out. Yeah, and this version of the model actually thinks that there are a lot of clocks on this page. So segmentation is more detailed. Gives you a more rich view of what's going on in the picture, and it can be kind of surprisingly extraordinarily accurate about where the objects are in the picture. And it's kind of interesting to see the difference between this model and the previous one. All right, so again, your goal here is just to look through these examples, look through some examples, and see what you see. What are the differences between this model and the other one? What is it doing well? What is it not doing well? The last thing you're going to do, which I'm not going to run for you because it would take way too long, we're going to actually start with this pre-trained model. So I made a fresh copy of the YOLO 11 object detection model. And we're going to train it for 20 epochs on a different object detection task. So COCO identifies certain kinds of objects and not others. We're going to train it on the Kitty dataset, which was designed for autonomous vehicle use. So it doesn't identify household objects, but it does identify things that you might see in the road. So cars, motorcycles, maybe pedestrians, things like that. So we're going to try having you on your own run this. Train it for 20 epochs. If you're running it in Colab with the use of GPUs, even the free level, took about 30 to 40 minutes for me for it to train those 20 epochs, and it looked like it was doing a pretty good job. So what you'll do is you'll run this code block. It produces a whole lot of output. I'm not going to go through it. And then at the very bottom, I have found a few images from online that are from dash cams, and I just uploaded one to try, and I asked it to predict it and to show the results, and here are the results. So you can see that even with just 20 epochs, it's doing pretty well. It's possible that this is not a realistic test. I'm not sure off the top of my head if COCO includes things like motorcycles as well. So this could just be doing COCO results, but it is we'll at least try on a number of different images and see if we can figure out if it's starting to adapt. You would like to run more epochs than just 20 when you're talking about a task this complex. I'm trying to keep the time limited, so I'm only going to ask you to do 20. But if you have time to let it run for 40 or 100, you might see significantly better results. And certainly it was the case that the loss values were still dropping when I finished the 20 epochs. All right, so this is just a really fast overview of the Colab Notebook, the activity that we're going to do together just to explore these things, one of the things I want you to note is just how straightforward it was. This YOLO library, the Ultralytics modules are really user friendly, and you don't have to know a whole lot of coding to be able to build and use a model or even to train it on new data. The hardest piece is that new data, because building a data set for object detection or for image segmentation just takes a really long time. That's why I used a pre-existing model, pre-existing data that actually already Ultralytics provides, just to keep things really simple. But yeah, the hard part with object detection is building the model, building the data set in the first place. If you actually want to run it, it can be relatively straightforward to train a model like this. All right, I'm going to stop there, and I will see you very soon.